This video is about graphing lines in slope-intercept form, writing the equation of a line slope-intercept form from a table or a graph, identifying parallel slope, and given a line, graph a line parallel given a line. So yesterday we used equations in slope-intercept form in order to graph a line. So let's go in reverse now. So in number 1 and number 2, we already have the line drawn. We need to write the equation. So to find the slope, in this case, my line is going down. So I want to figure out how much I go down and over to get to the next dot. So I went down 3 and right 1. So my slope is negative 3 over 1, which is negative 3. My y-intercept would be 0, 5, because that's where I'm crossing the y-axis. So in this case, my equation would be negative 3x plus 5. In number 2, since there's no dots on the line, I'm going to find two places where my line nicely crosses the grid line. So I'm going to pick here and here. So in this case, my slope is positive because I went up and over. I went up 1 and right 2. So my slope is 1/2. My y-intercept is where I'm crossing the y-axis, which in this case is 0, 4. So my equation would be y equals 1/2 x plus 4. So now let's look at parallel and perpendicular lines. So parallel lines are lines that will never touch. So parallel lines always are going to have the same slope, but different y-intercepts. Perpendicular lines are lines that intersect to form right angles. Perpendicular lines always have slopes that are going to be opposite reciprocals. So let's look at an example real fast before we move on to our chart. So let's say, for example, that our slope was 2/3. So if we're going to have a parallel line, our parallel slope is going to be the same 2/3. Our perpendicular slope is the opposite reciprocal. So the opposite means that we switch the sign, and reciprocal means we flip the fraction. So it was positive, which means my slope is now negative, and then I flip my fraction, so it now becomes 3 over 2. So let's try some more slopes of parallel and perpendicular lines. So in the first equation, we have y equals 5x minus 4. So our slope here is 5, which means that the parallel slope is the same, which is also 5. Now remember, if we have a constant number such as 5, we can write that as 5 over 1, which will help us with the perpendicular slope. So the perpendicular slope is the opposite reciprocal. So I need the opposite sign, which is now negative, and I'm going to flip that 5 over 1 to become 1/5. In the next one, y equals negative 2/3 x plus 9. So our slope is negative 2/3. Our parallel slope is also negative 2/3. So the perpendicular, it was negative, so it now becomes positive. And I'm going to flip that fraction to become 3 over 2. In the next equation, the slope in front of the x is 5/3, remember, or 5/4. Remember, we always want the number in front of that x. So 5/4. My perpendicular slope, so I need the opposite sign, which means it's negative again, and take the reciprocal, so I flip that fraction to become negative 4/5 then. Now in the next one, before I can do my slopes, I need to solve for y. So I'm going to divide everything by 5 here. Y equals negative 3x plus 11. So that means that my slope is negative 3, or we could say negative 3 over 1. My parallel slope is negative 3. And my perpendicular slope is the opposite reciprocal. So I'm going to make it positive now and flip my fraction to become 1/3. In the next problem, before I can do my slope, I need to add 6x to both sides. So y equals 6x plus 8. Remember, you can only find slope if you are in a y equals form. So to find my slope, it's the number in front of x, which is 6, or we can write that as 6 over 1. My parallel slope stays the same as 6. And my perpendicular slope is the opposite reciprocal. So it's going to become negative, and I flip my fraction to become negative 1/6 now. In the last one, in order to find our slope, we need to solve for y by doing two things. First, we're going to subtract 4x from both sides. Negative 10y equals negative 4x minus 90. And then we're going to divide by negative 10 everywhere. So when I reduce that, I get 2/5 x plus 9. So my slope is 2/5. My parallel slope is the same as 2/5. And my perpendicular slope is the opposite reciprocal, so the opposite sign, and flip that fraction, so it becomes negative 5/2. So now we're going to determine whether lines are parallel, perpendicular, or neither, given two equations. So make sure that we're finding the slope. So in the first equation, they already gave us our slope as negative 1/3. In the second equation, I need to solve for y first before I can get my slope. So I'm going to subtract 5x from both sides. 15y equals 5x plus 60. I'm going to divide everything by 15. Y equals negative 1/3 x plus 4. So my slope is also 1/3. Because these lines have the same slope, that means that they are going to be parallel lines. In number 4, my slope is 2/3. So then in the next equation, I need to solve for y first. So I'm going to add 12x to both sides. 8y equals 12x minus 40. And I'm going to divide by 8. Y equals, when I reduce this, 3/2 x minus 5. So my slope here is 3/2. Now, while this is a reciprocal, they do not have opposite signs, so it can't be perpendicular. This is a neither. Number 5. The first equation, I need to subtract x from both sides. So I get y equals negative x plus 9, which is really negative 1, that I can write that as negative 1/1. In the second equation, first I need to subtract 5x from both sides. So negative 5y equals negative 5x plus 10. When I divide by negative 5 on both to everything, y equals x minus 2. So if there's no number in front of x, remember that's just a positive 1, which we can write as 1/1. Now this is a tricky one because it's the same number. The reciprocal looks the same, but we actually did a reciprocal because if we flip 1/1, we still get 1/1, and they're opposite signs, so in this case the lines are perpendicular. Now let's do the same idea looking at the slopes from a table. So in the first table, our y's are changing by plus 10, and the x's are changing by plus 8. So 10/8 reduces to 5/4 because I can take a 2 out of both. In the second table, we have 5 for the y's changing, and the x's are changing by 4. So because these slopes are the same, the lines will be parallel. In the second table, to get from 5 to 8, I'm adding 3. And to get from 8 to 6, I'm subtracting 2. So my slope would be 3/2. In the second table, we're adding 2 for the y's, and we're adding 3 for the x's, so my slope is 2/3. In this case, we have opposite signs, and the fractions are flipped, which means that they are reciprocal, so these lines would be perpendicular. Number 8 and 9, draw a line parallel given to the line through the point 3, 1. So first we need to look at this line and see what is the slope of the line. So when I look at the slope of the line, I went up 7 and right 3. So if my slope is 7/3 of the line, the parallel slope is also 7/3. So I'm going to plot the point 3, 1 And then I'm going to use that slope. So I'm going to go up 7 from that point, right 3 from that point, and because I can only fit one dot, I'm going to connect my lines. Notice that the lines have the same steepness, so they're never going to intersect. Number 9, draw a line parallel to the given point through the point -3, -5. So when I look at this line, I have a positive slope. So to find my slope, I went up and over. So I went up 1 and over 6. So my slope is 1/6. The parallel slope, remember, is the same, so that's also 1/6. So I'm going to go to the point -3, -5 to start my initial dot, and then I'm going to use that slope up 1 over 6, and I can do that one more time, up 1 over 6, and then connect those points to form my line.